the technical part. I'd like to start my first question to Matt. Little buzzword bingo, adding some more. We heard about BIM, we heard about decarbonization. I add artificial intelligence, I add IoT. How do you see these topics? What role do they already play? How do they contribute to further developments? And how can they contribute to decarbonization and to contributing to high comfort for users in the building?
That's a good question. I think maybe I wonder, are you referring more to building design or operation or both?
Both. It's okay. From your professional experience in your field, how do you see it?
I mean the thing that's like asking me what the question is, like Internet of Things, artificial intelligence, like those are kind of buzzwords right now, especially in lighting controls. And what comes to mind is that the development of the technology, I think, has outpaced the capabilities of end users and owners to like really understand and comprehend what they have, what they can do. They Brendan, you mentioned the lights in this room like are not responding to daylight, though they probably should. And there probably is controls that allow that, but it's not functioning. So like we want to make sure that what we design is usable, and the technology that's available can do a lot of stuff, but it's more about designing a system that works. And I think maybe there's a role that AI can play in that, like machine learning, and maybe there's some sort of system that kind of learns how the building interacts and can adjust things accordingly. But I think in the short term, there's opportunities for integration of systems. One of the healthcare clients that we're working with, we've been doing some research on lighting controls and how those might integrate with their overall BMS systems, which I think is a topic that that has been discussed since I started my career over 20 years ago. And I think there's still not a really good solution for a like converged control system that operates everything. Like you still have the lighting controls, the building controls, but like getting to the point where you don't have a separate sensor for occupancy for the lighting and occupancy for mechanical. So I think that's the opportunity, but we as an industry and as designers need to do it in a way that is workable for owners so that they're not installing systems that nobody can understand and can't be worked on later. So there's a lot of, the technology I think is there. It's how do you use the technology in a way that works for everyone?
Thank you. Just an add-on question to that. Do you think that changes when using AI? To my view, it is already currently like that. Even not using AI, controls are not understandable. People, they need to rely on it, and if it works, it's great, and if not, we're in here. So
yeah, I think, and this is just me thinking, but maybe there's a way, and maybe there's been research in this already, but maybe there's a way to integrate machine learning or AI into control systems more than they currently are, so that it's sort of like, I can imagine like this room, for example, it's set to do something and it's going to do that until somebody changes it. But maybe there's sort of a default where the room does something until you, as a human, interact with it. So instead of the baseline being like, you're in the room, lights are on, baseline is something else that's kind of learned from how occupants move around the building and how it's used. Sort of like the idea of pre-cooling the building. Maybe there's some element of lighting and shading that work with that as well. So there's not really an easy answer to that.
Thanks a lot. My second question I would have for Brendan. It was great to see you showed all the simulations you do, and it's part of Voices and Nubolodi. I hope that's pronounced correctly. And I know a lot of work that you did, and it's always great to see, and you use all the tools. So as we are dealing with tools in that subtask here, so what is your main pain points still thinking about the tools that you use in lighting design for integrated solutions?
Yeah, it's a great question, and I'm just really glad to see that you're continuing to focus on Energy Plus and Radiance, because they're two incredibly robust engines that we have validated over and over again as being incredibly accurate if used correctly. And also that because they're based in root physical principles, we can use them inaccurately in ways that are useful, which is also wonderful. So, this gets to the root of your question though, because there are very few guardrails on the engines, because they're physics engines. It means that a novice user can use them incredibly inaccurately very easily. And without having expertise, they might have no way of knowing. This happens all the time when we train people in our office. We'll ask them to produce some results, and then I'll go over and look at the results and go, I don't think this is physically possible in space. And then we'll go through a few hours of troubleshooting what happened. So that's the pain point, but it's also the great amenity that such powerful tools have. I wouldn't change it. Let me underline that. I wouldn't change it. What I would do is to have a much more robust global network that is continuously validating software and the simulation tool engines. Because, I don't know, Greg's in the back there, he probably knows better than anybody. Maybe there's 500 expert users of Radiance around the world.
That number is probably high.
So, okay, I was gonna say 50 first, and then I thought, that's more than that.
Well, it depends on what you mean by expert. Do you mean people who use the tool directly and know its parameters and its algorithms
Yeah.
and set them correctly? Then yeah, a few hundred.
So a few hundred people, which is a ridiculously low number for the amount of time the software's been available and the power of the software. There is no other simulation tool that can do what Radiance does as well as it does it. And yet, it has almost no adoption at a widespread expert level. Now, if you take that and you say, how about the novice users of Radiance, which includes all of the sort of rebranded containers, user interfaces, etc. And there's probably tens of thousands of people who use Radiance at a novice or unexperienced level and have no idea what they're getting out of it. Now, to a certain extent, that software puts on guardrails, already, which is probably a good thing for that user group. But it also, because it puts those guardrails on, it limits what you can do with it. So my advocacy would be to see if there couldn't be much more widespread adoption, understanding, expertise, validation, and support for the two men back there who are doing amazing work, but it's just two people. I mean, it's really Tao Ning and Greg when you
Well,
can do
actually,
it.
the development community includes David and other people who are actively pursuing advanced features. But yeah, it's.
But I
it's
mean,
a small group.
financial
It's a-
support is what I'm saying. because they're really, it's a global community that's largely voluntary, which is ridiculous for the most powerful lighting simulation engine we have. I mean, it's embarrassing almost as an industry.
This goes back to what Mark was saying, is the funding is going away from windows to heat pumps. So if we want more funding for these guys, we have to go and ask our elected representatives.
But I gotta ask a quick question. So before somebody characterized my comment. So I wasn't saying that the tools need to be simple, right? The tools can be extremely complex, but they have to be very easy to install and to use. And getting back to the software, right? Radiance is great, all these things. But the thing is, at the end of the day, if we really need this providers of daylighting components, right? Who out there can really benefit from this? Like, in other words, how do we look at where's the business model? Right? So how can I get the business model that will say, okay, if I use Radiance and I tell people this is how you can do your evaluation, and then you use my products, right? Somehow, it's great that we have the expert users to keep working at new things, but if we don't get it to the masses, it's gonna stay where it is. It's gonna stay as a niche application. One of the questions we had about this evaluation, it was all Europe, or the rest of the world didn't have North America in there. One of my questions is gonna be, some of those people in the user group about virtual, does anybody know if any of those people were using Radiance?
Well, they're not using it in virtual environment because it doesn't exist as a virtual environment. That's just
Well, I guess the
that's
professional
one
ones.
great example.
See,
right there.
I think Radiance is a
Why
virtual environment, so I don't know even the difference is how bad I am.
Why don't we have VR Radiance? I mean, the answer is it's incredibly complex and it's computationally expensive. But so what? I mean, there's a million.
You guys have a great computer here, just figure it out. I mean, that's why we hired the national lab. You guys can figure this stuff out.
Exactly.
Just to add, I think I want to like what I taught at the MFA program at Parsons before I moved out here, MFA lighting design, and I taught a studio that was about the interaction of daylight and electric lighting. And one of the things that the students there, and I think as designers and architects we get focused on this as well, is that the output, like our output is not the analysis, it's the building, it's the end product. And I actually don't think, I completely agree with everything you said about Radiance. I don't think the limitation to good daylighting design is like the development of Radiance or the availability. I think it's the education about what is good design. I think we need to focus on that, because we have the tools, and yes, we should continue developing the tools and adding to them and all this, but it's more about like, how do you use this analysis to improve your design? And that's what gets missed a lot, I think, especially in education. It's because people get focused on, this is a cool colored image and I'm going to put it up on the screen and here's a graph, but like, what does it mean? And that's where we need help.
So that's human expertise.
Yeah.
Is what that is in interpreting the image. But the pain points for the software itself is the adoption.
But is it also using the tool to then provide guidance that can be used by people? Like, I'll admit, I talked to Ellen about some of these charts, right? I'm an engineer, I've been working this stuff is complicated. You got to dumb it down for people. You got to find a way to dumb it down, right? Because these people, you're not going to do it.
Well, to Matt's point, it may not be important to show them that.
Right. Just tell them what they need to do.
As long as the designers can learn from it, and as long as it can build intuition, understanding, then if it's too complicated for a layperson to understand it, which is perfectly fine, then they don't need to see it.
I'll say, like, on this point, when we're showing clients different daylight options, we probably get more response with a metric of like the percent of the time the shades are down versus like a daylight autonomy or amount of foot candles, et cetera. That they can relate to, and we say this design, the shades are going down 80%, so you're not going to see the view. They'll respond to that versus 20% daylight autonomy.
Just want to go back to your both points, and I think it really goes back pretty to what we see in the VR survey, that it's we need education for people in terms of radiance and daylighting design, and would use that exactly experience the same. People should get the education to understand themselves, that they do a simulation and they see the result and see that's not possible. That's just not true, and they give you that and say, okay, but Radiance said that it's like that. Okay, Radiance said it, but it's as I say, we can have reflectances like above 1. Okay. It's possible there.
But has anybody ever laid out the customer or the people that need like a matrix of who needs what at what level? And are you communicating to the people that need it at that level? I mean, academia and all the researchers, you guys can geek out all you want, but at the end of the day, you need to translate that information to people that are going to use it every day. The people that are going to say, "Oh, I'm going to buy light fixtures. I'm going to do this. I'm going to buy shading." Like even the architects may be on the high end of your customer base. There's so many people that put in daylighting measures every day that aren't architects. They're much lower sophisticated than architects. So how do you get to those people? Like, there's tons of buildings in America that get built without architects, right? They just build them. They just build them really simple. They're like, okay, we just put up a strip wall.
I would argue that simulation, that's not the audience for simulation tools.
No, but the simulation tool output that gives you the guidance as to how to implement it. We need guidance as to how to implement technology into the real world.
So in this space, the manufacturer has guidance on where to install the photosensor relative to the window wall.
Okay.
And how to program the controls so that the lights are dimming. There's no amount of simulation that's going to tell us that these lights shouldn't be on. So we know that we don't need it.
Right. But there could be a program that says you get a text message saying you're out of calibration. You need to do something here. Like National Laboratory building that's state of the art. If it doesn't work here, where's it going to work? I'm just being honest. Where's it going to work? If it can't work here, we're going to get to work. I mean, you think about the expertise that exists in this room. Right? I mean, so tomorrow, can we come back and see it working? I mean, how long is it gonna take to get this thing to work? I mean, this is what I'm telling you. If it takes 3 PhDs to install this system in this room, we fail. Okay? It should be an electrician can put this stuff in, a regular electrician, not a mass electrician. A journeyman electrician can install this stuff and get it done right. If you can't get to that level, we don't get it.
Yeah.
All right. I'm just saying that.
I mean, this is the master of radio.
That's what radio is about.
But I think to your point, one of the things that like the AI development might guess, and I feel like I remember seeing this on product data like 15, 20 years ago for occupancy sensors. It was a self-calibrating occupancy sensor that kind of understands how frequently the room is. But maybe a step to what you're getting at is a lighting control system that just you put it in, you power it on, and then that's it, and then it sort of programs itself. I don't know how to do that.
And then when it fails, it tells you, hey, I'm failed.
Yeah.
Something like that.
Yeah. So like maybe that's a sort of step, that AI can help with, or maybe it's just regular technology, but like that's kind of what we need so that you don't run into this as much.
One more comment.
Yeah, I don't know, is the discussion already open? Does it move on?
Yeah.
No, I was just wondering if we don't need other tools. I mean, going to the installers, which for instance in Europe make maybe 70 or 80% of the project. We have high-end projects for the architects, but that we give those people very simple tools, and maybe IEA can help them automating the design process, not the controls themselves. In the presentation, I've shown an example from our institute. They had a hallway installed. They just took their standard luminaires they always take, and in the end, we got 1,000 lux installed instead of 100 lux. And so that is really a lever where we could look at. And we are seeing AI or automations, for instance, in stadium illumination, where the designers are bringing down the time they're putting into projects from like 5 days to 1 day, only with the help of algorithms. So the photometry is one thing, having it good with radiance and other tools, but making the whole design process, not making designers obsolete. That's not the question for the high-end project, but targeting a little more at electro installers, people who are doing day-to-day design.
Yeah, it's maybe I can add as well. Is if we are on these topics of the installers and people who should take care of that. Actually, that's kind of happening as well, because besides the work with the project, as well recently involved with a project with Green Energy Croatia, that they actually have problem with not enough people that are trained to be installers for the solar panels. So they want us to actually develop the training that would, on different levels, because obviously there are different certification of installers, teach people how to do this. Because there's a big demand, and the risk as well connected with the training is big, like panels usually on the roofs and so on. So we are cutting the risk during the training, and as well scale it up very quickly, because there are not so many facilities that actually can do the training. So just that.
Okay. So I think to move on, one last, and closing it with a reply to your point, I think in here we might have the possibility to change the control by tomorrow, but I guess getting it back to policy, we're not allowed to. We were hardly allowed to come on campus. I'm pretty much sure we may not do it ourselves.
I know. I'm just saying. There's lots of difficulty. There's lots of difficulty. I mean, how many times do people see the lights on with the right below a sky? They put a electric light right below a skylight. In the middle of the daytime, it's on. I mean, it drives me crazy. I tried.
Okay, so let's move on to the case studies. Well, thanks a lot for the discussion.